Hello, folks. How is it going? Mike coming back at you here with another video on discrete mathematics. In the previous video, we talked about arguments or argument forms. We talked about valid and invalid arguments. We talked about what does it mean for a valid, or what does it mean for an argument to be valid or not. And we talked about how we determine whether or not an argument is valid. And we do that through the use of truth tables. We saw a couple examples of what an argument or argument form looks like. And then we talked about a couple really basic valid argument forms, modus ponens and modus tollens. As we said, in this video, we are going to go through the two examples of arguments or argument forms that we saw inside of the notes, and we are going to see if these are valid arguments or not through the use of truth tables. So here we have the first one that was listed. We had our two hypotheses, P or, Q or R, as well as not R, and then therefore our conclusion of P or Q. Now just notice here with this first hypothesis, I didn't have to include the parentheses on Q or R because we are doing it two disjunctions here. It's all the same sign there. We wouldn't have to put those there, but for sake of clarity and for the sake of doing a truth table, I included them here. So the first of our three steps, just as a quick recap of using truth tables to determine whether or not an argument form is valid. First step is to complete the truth table. The truth table for an argument form has to contain a column for each of the hypotheses in the argument form, as well as a column for the conclusion. So step one, you're going to completely fill out that truth table. Step number two, you're only going to focus on the rows in which all hypotheses are true at the same time. These are called the critical rows. And we can circle these, we can put arrows next to them, whatever it is that you want to do just to highlight those rows. And then step number three, we are going to look at the values of the truth tables. We're going to look at the values of the conclusion in those critical rows. And what we want to see in order to have a valid argument is that whenever all hypotheses are true, then your conclusion has to be true as well. So let's start off with going through this truth table. Let's start to fill in these columns. So we're starting off with Q or R, just a basic disjunction of the second and third columns here. So if you do that on your own, not that hard to see that the column Q or R goes T, 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 F, T, 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 F. Filling in our next column, this is one of our two hypotheses. We're taking the disjunction of the first column and the fourth column. So again, very basic, or it should be by this point, considering all the experience we've had with filling out truth tables with disjunctions. When you complete the fifth column, you get all of them T's except for the last row, which is an F. Next column is the other hypothesis, not R. This is really easy, really straightforward to fill out. You're just switching the values of R in the third column. So anywhere in the third column where you have a T, in the sixth column it becomes an F, and vice versa. F's become T's. So note now that we have all of the columns for our hypotheses. We know all of the truth values. for all of our hypotheses. We're now going to go ahead and fill in the last column, the simple disjunction of P or Q. So disjunction of the first two columns, really straightforward, TT, 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 FF. So this is step one of our three-step process to figuring out whether or not a given argument form is valid or not. You're going to completely fill out this table. Step two, identify all the rows that have all the hypotheses being true simultaneously. So these are the columns that contain the two hypotheses for this particular argument form. We want to see in what rows are both of these things true. And I'm going to sort of highlight these rows by putting an arrow next to them. So as I go down these rows, I see, okay, first row, there's a true and a false, so not concerned with it. Second row, there's a true and a true. That is going to be one of my critical rows. I'm going to put an arrow next to that because that's a guy that I want to focus on. Third row, a true and a false, don't care. Fourth row, a true and a true. That's going to be another one of my critical rows. Fifth row, true and false, don't care. Sixth row, true and a true, another one of my critical rows. And then row 7, true and false, don't care. Eighth row, false and true, don't care. So we have three critical rows that we have to look at, the second, the fourth, and the sixth. Let's look in the conclusion column, namely P or Q, and if in the second, the fourth, and the sixth rows, if our conclusion is true for all of them, then this is a valid argument form. If even one of them is false, then this is not a valid argument. This is not a valid argument form. So P or Q in row 2 is true. In row 4 is true as well. And in row 6 is true as well. So we've checked. We've seen that for every one of the cases where all of my hypotheses are true simultaneously, the conclusion is also true. This is what says we know that this is a valid argument. So we can say, therefore, the argument is valid. And that's all you would have to say, or the argument is not valid, and you can circle the particular truth value for the conclusion in a row that would not be true. But basically, all you're doing for these problems is very, very similar to what we have been doing so far up until this point. We're just filling out values in a truth table. So let's go on to another example. This is another case where we have two hypotheses and then our conclusion. This time the hypotheses are P implies Q as well as Q implies P, and our conclusion is P or Q. We're again going to fill out this truth table to see if this is a valid argument or not. And actually what I'm going to let you do at this point is pause the video here and try this on your own. Try to figure out on your own if this is a valid argument or not. But just think about the three steps that we have done here. You fill out your entire truth table. You then look at the rows in which both hypotheses are true simultaneously. aka the critical rows. And then in those critical rows, check the truth value of your conclusion. If your conclusion is true in every critical row, then your argument is valid. If it's not true in every critical row, then the argument is invalid. So pause the video here, try this on your own, and then once you think you have it, press play, and we'll see if you got it right. Okay, so let's see if you got this right. We start to fill out our rows in this table. This is a very nice, short, easy problem. Nothing too complex happening here. There's only 3 more rows that we have to fill in. So P implies Q. Thinking back to our truth table for the conditional, a true implying a true gives me a true. A true implying a false gives me a false. A false implying a true gives me a true. And then a false implying a false gives me true. And we'll also do the other conditional that we have. We'll take care of the other hypothesis here. We'll do Q implies P. Once again, just as a quick reminder, be sure to follow the proper order because the order does matter when you're talking about the conditional. We have a true implying a true. That is true. We have a false implying a true, which is true. We have a true implying a false, which is false. And then I have a false implying a false, which is true. So these are the values, the truth values for our next 2 columns. These are the truth values for each of our hypotheses. Now, I said that the first step of our 3-step process is to completely fill out our table and then move on to step 2. I will mention this little shortcut you can take. Be very careful with it though. It's nothing too crazy, nothing too tricky. You shouldn't really get caught up on it, but just be careful with this shortcut. Don't get it messed up because then that could lead to an incorrect final answer or incorrect final determination on whether or not you have a valid argument or not. We said we're only concerned about the rows in which both hypotheses are true simultaneously, right? So instead of completely filling out the column, the final column, which is the column for our conclusion, once we filled in the columns for each of our hypotheses, let's just highlight the critical rows there, and then let's only find the truth values of our conclusion for those particular rows, because those are the only things that we care. These are the only things that we care about when it comes to determining whether or not we have an argument that's valid. So I'm going to pause here. I'm going to say, okay, let's look in my columns for my hypotheses, which are the 3rd and 4th columns. In what columns do we have 2 trues happening at the same time? First column, that's happening, that's a true, and that's a true. A false and a true in the 2nd row, no go. A true and a false in the 3rd row, no go. And 4th row, we have a true and a true. So that is going to be another one of my critical rows. So we have 2 critical rows here. For each of these 2 critical rows, let's find the value for our conclusion, P or Q. The disjunction of a true and a true is true, and the disjunction of a false and a false is going to be false. So now we look, we have a critical row, specifically the fourth row here, where all of our hypotheses are true, yet our conclusion is false. And although it's only happening in one of these two rows, that's still enough for us to say that this argument is invalid. So therefore, the argument is invalid. And once again, all it takes is for one critical row, one row where all the hypotheses are true and the conclusion is false, to say that the entire argument is invalid. So this is the little shortcut that you can do. Saves you a little bit of time, not a ton, but once you have all of your hypotheses, once you have all of the truth values for each of your hypotheses filled in, you can then figure out your critical rows, and then from there only find the truth values of your conclusion for those critical rows, and you can just do that to come up with your final determination of a valid argument or not. In this last slide, I did just fill out the last column for those of you who would like to stick with the three-step method that was given, and you can then highlight the rows, circle values, whatever, and you would arrive at the same conclusion. So these were just a couple sample problems to see how we use truth tables to determine whether or not an argument is valid. In the next video, we are going to take a look at some more logic. We're going to be moving into a new we are actually going to be continuing on with argument forms, seeing some other types of valid argument forms. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.